Continuing on with u substitution, the next set of problems don't give us exactly what we want as far as having du already in the problem. So let me show you how that complicates things a little. I here see that I have 7x squared plus 4 to the 9th. So I'm going to put in u equals 7x squared plus 4. When I take the derivative of the left side, I get du. When I take the derivative of the right side, 2 comes down, makes it 14x dx, and this 4 goes away. Here's my issue. I only have x dx. I want it to say 14x dx. So in order to introduce a 14 into this problem, what I really have to do is introduce a 1/14 out front. So what I'm actually doing to the equation is I'm putting a 1/14 as a fraction in front. I'm saying it's the integral of 7x squared plus 4 to the 9th times 14x dx. As you can see, the original problem and the new look of the problem, the key difference is, instead of just having x, I now have times 14 here. Instead of having nothing in front of the integral, I have 1/14 here. So basically, as long as this 14 times this 1/14 as a constant would just become 1, which we already had originally, I haven't mathematically changed the problem at all. But what I have done is I've now allowed myself to move to the world of u's more easily. So 1/14 stays out front. It becomes the integral of u to the 9th du. No x's left over. Everything lines up. If I now integrate, that 1/14 stays. U to the 9th becomes u to the 10th divided by 10. And then I need my plus c. In this case, u to the 10th times 1 is still u to the 10th. Or if I plug back in for x, it's 7x squared plus 4 to the 10th power. 14 times 10 gives me 140, which is the bottom of this fraction. I then add c, and that's the correct final answer. By far the most confusing thing about this type of problem is getting that fraction right. But if you don't have that fraction right, you won't have the final answer right. If I look at b, again, it's fairly easy to identify what the function is that's being taken to a power that really is the chain rule application. It's this 3x squared minus 5 that's being taken really to the -5th power. So I'm going to set up u equals 3x squared minus 1. Then I'm going to take the derivative. The left side gives me du. When I take the derivative of the right side, 2 comes down, gives me 6x dx. What I currently have is 2x dx. In order to turn that into 6x dx, I'm going to have to multiply by 3. Since I'm multiplying the inside of the equation by 3, on the outside I need a 1/3 to undo that. So it's going to become 1/3 the integral of 3x squared minus 1 to the -5th times 6x dx. So again, all that I've done is brought this to the top as a negative exponent, took what was 2x, multiplied by 3 to get 6x dx, which is my du. Because I multiplied the inside by 3, I had to multiply the outside by 1/3. I'm now going to replace u's wherever I can, so it becomes 1/3 the integral of u to the -5 times du. When I integrate, I add 1 to this exponent, so it goes from -5 to -4. I divide by the new exponent, -4. So it becomes 1/3 u to the -4 over -4 plus c. When I clean this up a little, this u to the -4 comes to the bottom as u to the +4. 3 times -4 gives me -12. So I get 1 over -12 times the function that we know is u. In this case, 3x squared minus 1, being taken now to the +4th power on the bottom, all plus c. Final problem here, part C. I have x to the 5th over 10x to the 6th plus 21 squared. Again, I'm going to identify the part on the bottom that's being squared as my u. So I can set up that u equals 10x to the 6th plus 21. If I take the derivative, on the left I get du. On the right, 6 comes down times 10 to give me 60x to the 5th dx. The 21 goes away. So now what I have in my equation is x to the 5th dx. What I want is 60x to the 5th dx. So when I rearrange my integral, I'm going to bring 10x to the 6th plus 21 to the top by saying on bottom it was a positive second power, on top it'll be a negative second power. Then instead of just having x to the 5th dx, I want 60x to the 5th dx, which means I've multiplied the inside by 60. I have to multiply the outside by 1 over 60 so that I haven't mathematically changed anything. If I now go about replacing my u's, 1/60th stays outside. It becomes the integral of u to the negative 2 du. When I integrate u to the negative 2, I add 1 to the power, so negative 2 becomes negative 1. I divide by that new power. So it becomes 1 over 60 u to the negative 1 over negative 1 plus c. When I clean that up a little, this u comes to the bottom. 60 times negative 1 is negative 60. So I end up with 1 over negative 60. U is on the bottom, in this case 10x to the 6th plus 21 to the understood first power plus c.